When measuring an unknown direct current voltage with a multimeter, the recommended practice is to begin by setting the selector switch to the highest direct current voltage range. This approach ensures the protection of the multimeter from potential overvoltage. If the actual voltage is lower than the selected range, the meter will display a low reading, but no damage will occur. Once a reading is obtained, the range can be progressively decreased until the display provides the most accurate and readable value. Grounding the meter or the circuit is not the initial step in measuring an unknown direct current voltage. The primary concern is to avoid overloading the meter by starting with a sufficiently high voltage range. Multimeters have internal resistance that allows them to measure voltage. The meter is placed in parallel with the circuit to measure the voltage drop across a component or section of the circuit. Selecting the appropriate range is crucial for both safety and accuracy. Using too low a range can damage the meter and give a false reading, while using too high a range can result in a reading that is not precise. Consider a situation where you are measuring a voltage in a circuit you suspect might be around 12 volts. If your multimeter has ranges of 200 millivolts, 2 volts, 20 volts, 200 volts, and 1000 volts, you would initially set the meter to the 1000 volts range. If the display reads 0.1 kilovolts or something similar, it indicates that the voltage is somewhere below 1000 volts. You can then safely switch the meter to the 20 volts range. On the 20 volts range, the meter may display 12.3 volts, which is a more accurate reading. If the meter displays an overload indication on the 20 volts range, it means the voltage is higher than 20 volts, and you should switch back to a higher range like 200 volts to avoid damaging the meter. The accuracy of a multimeter is often specified as a percentage of the reading plus a number of least significant digits. For example, an accuracy specification of plus or minus 0.5% plus 2 digits means that on a reading of 100 volts, the error could be plus or minus 0.5 volts, plus or minus 2 digits. If the least significant digit is 0.1 volts, the total error could be plus or minus 0.7 volts. Therefore, selecting the appropriate range to maximize the reading on the display is important for minimizing the impact of the accuracy specification. When using a digital multimeter, the meter typically has an auto-ranging feature, where it automatically selects the appropriate range for the measurement. However, even with auto-ranging multimeters, it is still good practice to start with a higher range to ensure that the voltage being measured does not exceed the meter's capabilities. The selection of the direct current voltage range also affects the input impedance of the multimeter. The input impedance is the resistance that the meter presents to the circuit being measured. A higher input impedance is generally desirable, as it minimizes the loading effect of the meter on the circuit. The loading effect occurs when the meter draws current from the circuit, which can alter the voltage being measured. By starting with a higher voltage range, the input impedance of the multimeter is typically higher, which reduces the loading effect. Additionally, it is important to ensure that the test leads of the multimeter are properly connected to the circuit. The red lead is typically connected to the positive terminal, and the black lead is connected to the negative terminal. Reversing the polarity of the leads can result in a negative reading or, in some cases, damage to the meter. Always double-check the connections before applying power to the circuit. Furthermore, it is crucial to exercise caution when measuring voltages in circuits that may contain high-energy sources, such as capacitors. Capacitors can store electrical charge even after the circuit has been disconnected from the power source. Discharging capacitors before measuring voltage is essential to prevent electrical shock or damage to the multimeter. Use a resistor of appropriate value and voltage rating to safely discharge the capacitor before taking any measurements. Safety is paramount when working with electrical circuits. Always disconnect the power source before making any measurements or adjustments. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Never work alone, and ensure that someone is nearby in case of an emergency. In summary, measuring an unknown direct current voltage with a multimeter requires a systematic approach that prioritizes safety and accuracy. Firstly, set the selector switch to the highest direct current voltage range. Secondly, decrease the range until the most accurate reading is achieved. Thirdly, ensure proper test lead connections and polarity. Fourthly, exercise caution when measuring voltages in circuits containing capacitors. Fifthly, prioritize safety by disconnecting the power source and using personal protective equipment. Following these guidelines will help ensure accurate and safe voltage measurements. Moreover, be aware of the multimeter's limitations and specifications. The maximum voltage that the meter can safely measure is specified in the user manual. Exceeding this voltage can damage the meter and pose a safety hazard. Also, be aware of the meter's accuracy and resolution. The accuracy specifies the maximum error in the measurement, while the resolution specifies the smallest change in voltage that the meter can detect. The resolution is determined by the number of digits on the display and the range setting. A higher resolution is desirable for measuring small changes in voltage. Before making any measurements, inspect the multimeter and test leads for any signs of damage. Damaged test leads can pose a safety hazard and affect the accuracy of the measurements. Replace any damaged test leads before using the multimeter. Also, ensure that the multimeter is properly calibrated. Calibration ensures that the meter is measuring voltage accurately. Multimeters should be calibrated periodically, typically every 1 to 2 years, depending on the frequency of use and the manufacturer's recommendations. Calibration services are available from various companies that specialize in electronic test equipment. When measuring voltage in a circuit, be aware of the potential for noise and interference. Noise can affect the accuracy of the measurements and make it difficult to obtain stable readings. To minimize noise, use shielded test leads and avoid placing the multimeter near sources of electromagnetic interference, such as motors or transformers. Averaging multiple readings can also help reduce the effects of noise. Additionally, be aware of the temperature coefficient of the multimeter. The temperature coefficient specifies how much the meter's accuracy changes with temperature. Temperature changes can affect the resistance of the internal components of the meter, which can lead to errors in the measurements. If the temperature of the environment is significantly different from the calibration temperature, it may be necessary to apply a correction factor to the measurements. The temperature coefficient is typically specified in the user manual. Finally, remember that a multimeter is a valuable tool for troubleshooting electrical circuits, but it is not a substitute for knowledge and experience. Understanding the principles of electrical circuits and the proper use of test equipment is essential for safe and effective troubleshooting. Consider taking courses or workshops on electrical safety and troubleshooting to improve your skills and knowledge. Before taking any measurement, double-check the circuit diagram or schematic to understand the expected voltage levels and polarities. This can help prevent accidental short circuits or damage to the multimeter. Additionally, be aware of the presence of any hazardous materials in the circuit, such as lead or mercury. Take appropriate precautions to avoid exposure to these materials. After completing the measurements, disconnect the multimeter from the circuit and store it in a safe place. Properly storing the multimeter will help protect it from damage and ensure that it is ready for use when needed. Also, dispose of any used batteries properly. Batteries contain hazardous materials that can pollute the environment if not disposed of correctly. Recycle used batteries at a designated collection point. When measuring voltage in high-voltage circuits, such as those found in power distribution systems, special precautions are necessary. Use a high-voltage probe that is designed for the voltage being measured. High-voltage probes typically have a high impedance and a voltage divider that reduces the voltage to a safe level for the multimeter. Also, wear appropriate personal protective equipment, such as insulated gloves, safety glasses, and a face shield. Never work alone when measuring voltage in high-voltage circuits. Ensure that someone is nearby in case of an emergency. Regularly inspect the test leads for any signs of damage, such as cracks or breaks in the insulation. Damaged test leads can pose a serious safety hazard. Replace any damaged test leads immediately. Keep the test leads clean and free from contaminants, such as dirt or oil. Contaminants can affect the accuracy of the measurements and pose a safety hazard. Use a soft cloth to clean the test leads. Do not use solvents or abrasive cleaners, as these can damage the insulation. When connecting the test leads to the circuit, make sure that the connections are secure and that the test leads are not touching each other. Loose connections or short circuits can damage the multimeter and pose a safety hazard. Use alligator clips or other types of connectors to ensure secure connections. When measuring voltage across a component such as a resistor or a capacitor, make sure that the component is properly rated for the voltage being measured. Exceeding the voltage rating of the component can cause it to fail, which can damage the circuit. Use a voltmeter with a high input impedance to minimize the loading effect in the circuit. The loading effect can cause the voltage reading to be lower than the actual voltage. A voltmeter with a high input impedance will draw less current from the circuit, which will minimize the loading effect. When measuring voltage in a circuit with multiple power sources, be sure to disconnect all of the power sources before making any measurements. This will prevent accidental short circuits or damage to the multimeter. Use a multimeter with a true root mean square voltage measurement capability to accurately measure alternating current voltages. True root mean square voltage measurement is more accurate than average responding voltage measurement, especially when measuring non-sinusoidal waveforms.